Hey guys, we're going to work through Saxon 113A together. So at the very beginning it says draw a 2 1/4 inch line segment. So let's do that part first. So you would do 1 whole inch, 2 whole inches, and then a 1/4 piece of the next inch at that hash mark right there. Not quite at half, it's between half and the 2, so that would be 2 1/4. And then they tell us to make it 3/4 of an inch longer than that. So I went to our 2 1/4 inch spot, and with a different color, you can see there's 1 more 1/4 of an inch, 2/4 of an inch or a 1/2 of an inch, and then 3/4 of another inch. So we didn't add on a full inch, we added on 3/4 size pieces of another inch. And now they want to know how long it is now. So I am going to do it this way to show you. We have 2 whole inches. We did 2 whole inches and 1/4 of another inch. Then we made it 3/4 longer. So 1, 2, 3 more 1/4 of an inch longer. Do you see how that gives us a whole nother whole inch? Because once we take the 1/4 that we started with, that went with our 2 whole inches, and then added 3 more 1/4s, we end up with another whole. So now this is 3 whole inches long. And let's double check it. It ends up being 3 whole inches long. Before we look at number 1, we need to remind ourselves that on a foot, which our rulers are a foot long, how many inches are on our ruler? There are 12 inches on our ruler, and our ruler is a foot long. That means that 12 inches equals 1 foot. So I've put 7 F's to represent my 7 feet or my 7 rulers. And each one of these feet has 12 inches inside of it. Once I make that visual, I can clearly see that is 12 inches per foot times 7 feet. And I end up with 84 inches. On number 2, I'm going to attach our video about angles. We're going to label each angle as acute, right, or obtuse. So this one, if it was a right angle, the vertical ray would be about right here, and it would meet at a perfectly square corner. But it's open wider than that, so it is an obtuse angle. This one, if I needed to turn it so that this ray is totally horizontal to me, so I can see it easier, but they're actually showing me that this does indeed meet at a perfectly square corner. So this angle is just right. On this one, I've turned it so I can see it better. My horizontal ray, I've turned where it's just straight horizontal for me. If this was a 90-degree angle, my vertical ray would be about right here, and it would meet at a square corner. But you can see it's closed much tighter than that. So this is an acute angle. Number 3 tells us these are cheesecakes. Divide the first cheesecake into halves. So I split it into 2 halves. Divide the second cheesecake into thirds, which means 3 pieces. Divide the last cheesecake into fourths, and that THS means 4 pieces. Each cheesecake will have 12 strawberries. Draw the strawberries on the cheesecakes so that each piece has the same amount. What we're actually doing is division. We are taking 12 strawberries and dividing them among the different amounts of pieces. So if I divide 12 strawberries among halves, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, each piece, 1, 2, 3, 4, 5, 6, is going to end up with 6 strawberries on it, because 12 strawberries divided among 2 pieces. is 6 strawberries apiece. So on this one, I can actually divide the strawberries up, or I can do 12 divided among 3 pieces. And 12 divided by 3 is 4. So once I actually divide out the strawberries, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, each piece gets 4 strawberries. So here I'm taking 12 strawberries and dividing it among 4 pieces. Well, 12 divided by 4 is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each piece gets 3 strawberries apiece. The way I do these without having to write them vertically is I think about place value. I'm going to multiply ones place to ones place. 3 times 2 is 6, and I put that in the ones place. Now I multiply the 3 by the tens place. 3 times 4 is 12, 12 sets of 10. So that's 126. Here, the 5 is going to multiply against the ones place. 5 times 1 is 5. Now the 5 is going to multiply against the tens place. 5 times 8 is 40. 405. Number 5, circle the letters with perpendicular line segments. As a reminder, the backbone on my D, I make it super long and put a line underneath. Perpendicular lines meet at a T crossing. So H has a set of perpendicular lines, L has a set of perpendicular lines, and T has a set of perpendicular lines. And I've colored those in where you can see they intersect at perfect squares or perfect right angles, or a T crossing. On number 6, we're going to have to do some regrouping. The bottom's bigger than top, so to my neighbor I will hop, but they don't have anything to borrow, so I keep going down the street. So now they have 3. The one I borrowed carries to the right, but I'm not back at home base yet, which is the ones place. So when this became a 10, now it becomes a 9. And I carry it back home. 10 minus 2 is 8. 9 minus 0 is 9. And 3 minus 1 is 2. On this one, I can't do 5 minus 7. If the bottom is bigger than top, to my neighbor I will hop. But they don't have anything, so I go down the street further. I borrow from the left and carry to the right. But I'm not at home base yet, which is the ones place. So I borrow again. That 10 becomes a 9. Carry to the right. 15 minus 7 is 8. 9 minus 2 is 7. And 8 minus 8 is 0. So 78. On this one, I may have to carry some. So 7 plus 1 is 8, plus nothing is still 8. 1 plus 3 is 4, plus 2 is 6. Drop that decimal down because the cents place only has 2 slots. 2 plus 8 is 10, plus 7 more is 17. So my 7 goes down, 1 goes to the rooftop next door. 1 plus 9 is 10, 11, 12, 13, 14. So my 4 goes down, my 1 goes to the rooftop next door. 1 plus 5 is 6, plus 5 is 11, plus 9 more is 20. So my 0 goes down and I'm carrying a 2. So that from left to right, even on different levels, that reads 20, because that's what my answer was in this column. 2 plus 3 is 5, plus 6 is 11. And I can't forget my dollar sign. And to the left of the decimal, we have the ones place, tens place, hundreds place, thousands place begins. So we would read this $11,047.68. On 113B, they ask us how many donuts are in 5 dozen. So I have 5 D's here representing the 5 dozen. And dozen means 12, so inside of each dozen there are 12 donuts. So just from the model or the visual, that looks like 5 times 12. So I've written that out here, and I like my bigger number on the top so I can do my up and over. And once we do our up and over, we end up with 60 donuts. So our number sentence would look like this. On number 2, they want us to draw an acute angle, which we know is going to be closed tighter than 90 degrees. So you may have drawn something like this. And then for a right angle, I actually put the little square there, and they do that because it can look like a right angle and be an 89-degree angle or a 91-degree angle. So it's best to specify that it is meeting at a square corner. And then your obtuse angle would be open wider than a 90-degree angle. So you may have drawn something like this. I did a little dotted line here just to show where if it were 90 degrees, it would be about right there, to show that it is open wider than that. Number 3 says these are cheesecakes. Divide the first cheesecake in halves. Divide the second cheesecake into fourths. Divide the last cheesecake into eighths. Each cheesecake will have 8 strawberries. Draw the strawberries on the cheesecakes so that each piece has the same amount. So we're basically taking 8 strawberries and dividing it in half. Well, 8 divided by 2 would be 4 strawberries per piece. 1, 2, 3, 4, 5, 6, 7, 8. Now we're taking 8 strawberries and dividing them among 4 pieces. 8 divided by 4 is 2. 1, 2, 3, 4, 5, 6, 7, 8. 2 strawberries apiece. Well, 8 divided by 8 is 1. So 1, 2, 3, 4, 5, 6, 7, 8. 8 strawberries divided among 8 pieces would be 1 strawberry apiece. On this one, to do it mentally without writing it vertically, think about place value. The 9 multiplies times the ones place, and 9 times 1 is 9, so my answer goes in the ones place. Then the 9 multiplies by the tens place. 9 times 2 is 18. 189. The 2 multiplies by the ones place, and 2 times 4 is 8. And then 2 multiplies by the tens place. 2 times 5 is 10. 108. On number 5, E and I have line segments that are perpendicular to one another, or that meet at like a T crossing. You can see where all of these horizontal lines would meet the backbone of the E at a T crossing, and the body of the I would meet at a T crossing with the feet of the I. On number 6, I'm going to draw my house in the ones place. That's home base. So I can't do 0 minus 7. If the bottom's bigger than top, to my neighbor I will hop, but they don't have anything to borrow, so I come here. Some of you put the one you borrowed there before you've actually taken it, so be sure that you take it first. So I'm going to slash it and borrow, and then I carry it. But I'm not back home, so that 10 becomes a 9 now. Now I'm back to home base. 10 minus 7 is 3, 9 minus 0 is 9, and 7 minus 1 is 6. 693. On this one, I'm going to put a little dot by my ones place. I can't do 1 minus 8. If the bottom's bigger than top, to my neighbor I will hop, and I have to keep going. So borrow it first, then carry it to the right. I'm not back in my ones place though, so we've got to borrow again. Borrow it first, then carry it. 11 minus 8 is 3, 9 minus 1 is 8, and 2 minus 1 is 1. 183. 7 plus 0 is 7, plus 3 more is 10. So my 0 goes down, the 1 goes next door. 1 plus 1 is 2, plus 8 is 10, plus 2 more is 12. So my 2 goes down, carry my 1 to the next column. 1 plus 1 is 2, plus 5 is 7, plus 1 is 8. So I don't have to carry anything because 8 is just a one-digit number. 9 plus 1 is 10, plus 5 is 15. 5 goes down, carry my 1. So that from left to right, even on different levels, my answer is 15. 1 plus 5 is 6, plus 4 is 10, plus 8 more is 18. 8 goes down, carry my 1. 1 plus 2 is 3, plus 7 is 10. There are 2 slots for cents, so my decimal goes there and my dollar sign. To the left of the decimal, I have my ones placed, tens, hundreds, thousands. So we would read this number, $10,858.20.